This video is on geometric sequences. We're going to use the recursive formula to help us write the explicit form and to find terms in the sequence. So geometric sequences are based off of exponential functions, so it's a multiplicative factor instead of adding and subtracting. So our first one says list the first 5 terms of the sequence. We're given a sub n equals a sub n minus 1 times 3, where a sub 1 is equal to 5. So what this means is our very first term is 5. We already have that. We need the first 5 terms, so that's the first term. Then we need the second, third, fourth, and fifth term. What we do to find the next term is just multiply by 3. We're going to multiply each of these terms by 3 to get the next term. So 5 times 3 is 15. Then we do 15 times 3 gives us 45. Then we'll do 45 times 3 gives us 135. Then we'll do 135 times 3 gives us 405. The recursive form is easier to use on this one than the explicit because I want the very next term instead of the 13th term. I want to find the first 5 terms, so I just multiply by 3 each time. On the next one, it also says list the first 5 terms of the sequence, given that a sub n equals a sub n minus 1 times 3/4, where a sub 1 is 400. So again, we know the very first term, and we need to know the first 5 terms. So that's the first, second, third, fourth, and fifth. So we list them out. In order to do this, we're going to multiply by 3/4. So each term is multiplying by 3/4. So 400 times 3/4 gives us 300. So that's our second term. Then we'll take 300 and multiply it by 3/4 again. We get 225. Then we'll multiply 225 by 3/4 and we get a fraction of 675 over 4. We'll then multiply this fraction by 3/4 and get 2025 divided by 16. These are our first 5 terms given our recursive form. The recursive form is helpful to know the very next term because it's the next equals now. So we just keep multiplying by 3/4. If we wanted to find the 29th term, we would use the explicit form, which is in a different video. So these next ones say write the exponential equation, which comes from the explicit form, and the first 5 terms of the sequence given the recursive equation. So the exponential equation, we need to be able to write the explicit form to help us write the exponential equation. The exponential equation means we need the a sub 0, not our a sub 1. We need our a sub 0. We need our y-intercept. So let's go ahead and write out the first 5 terms because that will help us determine all of our numbers. So our first term is 4. Our second term is we're going to multiply by 6 to get to our second term. So 4 times 6 is 24. Times 6 is 144. Times 6 is 864. Times 6 is 5,184. These are our first 5 terms. So to write our explicit forms, let's go ahead and write our actual explicit form of this. So it's a sub n equals our first term, which is 4, times our common ratio, which is 6, raised to the n minus 1. This is our explicit. Now the exponential equation comes from y equals a times b raised to the x. We need to know what a sub 0 is to be able to write our equation. So if we multiplied by 6 to get to our next term, we would need to divide by 6 to get to our a sub 0. So 4 divided by 6 is going to be 2/3. That is our y-intercept. We need that to write our exponential equation, which is what it's asked for. So our exponential equation is y equals, our y-intercept is 2/3 0, 2/3, so that's our a sub 0 number, times our common ratio, which is still 6, but now it's raised to the x because it's y and x go together. Using our recursive form to get our terms will help us to find our a sub 0. So on this last problem, we'll do the same thing. We're given a sub n equals a sub n minus 1 times 5/3, where a sub 1 is 8. So to find the first 5 terms, our first term we know is 8. And we're going to multiply by 5/3 to get the next term. So 8 times 5/3 is 40/3. 40/3 times 5/3 is 200/9. 200/9 times 5/3 is 1,000 divided by 27. And then that times 5/3 is 5,000 divided by 81. These are your first 5 terms. We use the recursive form to find our first 5 terms. So let's go ahead and write our explicit form in here because we have everything we need for the explicit. This would be a sub n equals our a sub 1, which was 8, times our common ratio of 5/3 raised to the n minus 1. Now to write our exponential equation, we need our a sub 0. So in order to get our a sub 0, we have to go backwards from our first term. So if we multiply by 5/3, we're going to divide by 5/3. So 8 divided by 5/3 gives us 24/5. This would be the a sub 0. So the 0, 24/5 would be our y-intercept. So 24/5 would be our y-intercept. So to write our exponential equation, we would use y equals, then we'd use the value from our y-intercept, 24/5, times our common ratio, or our growth or decay factor, and then raised to the x. So we use our 5 terms. Our first term goes to the explicit, and our a sub 0 goes to our exponential equation.